section for Chapter 2, Intermediate Algebra, Mat 1033. This is Section 7. This deals with absolute value inequalities. Now, the two example problems I'm going over are the only two types of example problems you can expect to see on a test. So I highly suggest that when you do your 8 problems for the homework, you do these 8 types. All right, first of all, same rules for absolute value equalities. This is going to be positive, so we got to make sure that this side holds true with the inequality sign. So with this right here, we got to look over here and say, okay, if this side has to be less than 2, is it possible for the absolute value of something to be less than 2? And in this case, it is. Because 2 is a positive number, there are numbers that are positive that are less than 2, we're in good shape. Remember, absolute value can't be negative. It can be 0, but it can't be negative. So we set it up. We take m minus 6 less than 2. The other thing you got to worry about is that when you set the absolute value up with m minus 6 and the negative 2 over here, you have to flip the inequality sign. So with equalities, all we had to do was change the sign of the constant on the right. Here we got to make sure we flip the inequality. So then I solve it. Add the 6, I get m is less than 8, which means I've got everything going this way. Add the 6, I get m is greater than 4, which means I have everything going this way. You can see the intersection is right here. This is what we're looking for. It goes from 4 less than m, which is less than 8. And here's how I write the interval. Parentheses 4, comma 8, parentheses. We come over here, same type of problem, same rules. First off, I've got to get the absolute value by itself, so I subtract the 1 over. Now I have absolute value of 5x plus 1 is less than or equal to 9. Are there positive values less than or equal to 9? Yes, so this is okay. So we set it up as 5x plus 9 less than or equal to 9, then 5x plus 1 greater than or equal to negative 9. Remember, when I flip this sign, when I change this to a negative, I got to flip the sign. Solving this, subtract the 1 over, divide by the 5, I get x is less than or equal to 8/5, which is this second graph here, where I have 8/5 and everything to the left. This one here, I subtract 1, I get negative 10, divide by 5, I get x is greater than or equal to negative 2. So here's negative 2 going this way. If I bring these two graphs together, you can see that from negative 2 to 8/5, they intersect. So there's my graphical solution. It's from bracket negative 2 to bracket 8/5, because again, when I bring these two together, I can see that it intersects in this area here. In order to write the interval notation of it, it's just bracket negative 2, comma 8/5 bracket, which is exactly what I have on my graph. See how my graph matches my interval notation. So here I have my algebraic notation. Here I have my graphical notation. Here I have my interval notation. Same thing with the first problem we did. Here's the algebraic notation, graphical notation, interval notation. Remember, when you solve these problems, you must have all 3 as answers for me.